Hi everyone, and welcome back to Odoistic channel and also to our new Python programming series. In this lesson, we are tackling a critical aspect of Python development, which is called error handling. By the end of this lesson, you will understand what errors and exceptions are in Python, how to use try, except blocks to gracefully handle errors, the importance of catching and managing exceptions to make your programs more robust, how to raise custom exceptions and handle specific error types. So, error handling is essential for creating reliable and user-friendly applications. Let's dive in. So, first of all, let's talk about what are errors and exceptions. In Python, errors are events that disrupt the normal flow of your program. They can be classified into two main categories. Number one, syntax errors. These occur when the code structure violates Python's rule. For example, as you can see, I'm using, as usual, Visual Studio Code. So let's start with print. Hello world. Okay, and now at the end, we are forgetting the closing parenthesis. Right. So if we will run this program, it will give us error, and this is called syntax error. As we are talking, this will raise a syntax error and the program won't run. Number two, exceptions. Exceptions occur during the program's execution. Common exceptions include zero division error, dividing by zero, value error, passing an invalid value to a function, and file not found error, accessing a non-existing file. So let's move on the handling exceptions with try except blocks. So what is a try except blocks? The try except blocks helps you handle exceptions and prevent your program from crashing. Here's the basic structure. So we will start with try, and then codes to handle the exception. Right. So this is the structure of try except block. First, we are starting with a try and then the code that might raise an exception. Then the risky operation. Then except block, and here the code to handle the exception. Because there is no risky operation, we have defined, that's why this yellow line you can see. So let's start with a real example how we can handle this. So as I have already explained to you, we start with try and we start with numerator, a variable, and here we start with int. We are converting an input right. I have already explained to you in my previous lectures that why we are converting into integer, because whenever a user is entering an input, that will definitely a string, and we are converting string into integer. So this is why we do this. So after that, we can create a new variable as well, denominator, the same integer. Okay, and result is equal to numerator divided by denominator, and then print, we say result right, and then except right. Okay, so if the denominator is 0, the except block catches the 0 division error and prints an appropriate message. If there is no error, the program prints the division result. So let's run this. Okay, so it's asking a numerator, so let's call it, we say number 4, enter, and now it's asking enter the denominator. So let's suppose if I enter 2 and press enter, so our result is 2, which is perfectly fine. So basically what has happened, so this after try, it has run the first line, take the input from user, then the second line, take the another input from the user, and then it has divided numerator with the denominator, perfectly fine, and it has not gone into this except block. But now if again I run this program, and now it's asking numerator, so I say 4, and it's asking denominator, so I say 0. In this case, it will go in except block because it is dividing by 0 now. Say it has said you cannot divide by 0. So this is a perfect example of handling try except block. If the denominator is 0, the except block catches the 0 division error and prints an appropriate message, which we have already printed, you cannot divide by 0. If there's no error, the program prints the division result. Okay, I hope you have understood this. Very simply, we have just defined that how we can handle it. So catching specific exceptions, you can handle multiple exceptions separately to customize responses for different error types. So let's do another example now. We start with try again. Enter the file name, with open file name, Sorry, it's so we're using read method here and print. Okay, now we use the accept block and file not found. The specified file does not exist. And accept permission error. Access. Right. So if the file does not exist, a file not found error is raised and the program informs the user. If there is a permission issue, the permission error is caught and handled appropriately. So this is how we can use file not found error and permission error. So let's run this again. So enter the file name, we say hello. So it said the specified file does not exist because there is no file exist. So, and if there will be any permission error, which we have not defined, so it will give a permission error. Right. Adding else and finally blocks. So else block runs if no exceptions occur. Finally blocks runs regardless of whether an exception was raised or not. And else and finally. So let me just tell you what I'm talking about. Why the else block is useful in ensuring that additional logic only executes when no errors occur. Or where we can elaborate on the practical applications of the finally blocks, such as closing files or releasing resources. So let me just show you one example. We try again with try. So number, so here we can handle except value error. That's not a valid number. We will handle this exception, and then we can also use else here, as I have spoken to you. Print no errors occurred. And then finally print execution complete. Right. So we could run this. Enter a number. So what I'm doing, I'm just entering 5, which is actually a number, and no error should occur. So it's saying you entered 5. You can see you entered 5, and then it has printed the fourth line, and then no errors occurred. So basically this except block has not been happened because there is no error. That's why it straight away go to else, and then it has printed no errors occurred, and then finally number 10th line, and then after that it has printed execution complete. Let's run it again, and now I am not entering a number, I'm entering a string, which is DEF. Press enter, and it has said that's not a valid number. Execution complete. So this is very, very clear, and in very simple example I have explained it to you that how we can use else block, finally block. If the input is valid, the else block confirms no errors occurred. The finally block always runs, making it useful for cleanup tasks. And then raising custom exceptions. We can use the raise keyword to create and raise custom exceptions. How we can do that? Why I'm showing you all these practical examples, because I believe that these practical examples are really very feasible and very helpful. Again, enter your age. Okay. If here we are using a condition, if age is less than 0, raise value and print if and then we can use except block. Okay. So let me just run this program. Enter your age. So if the age is negative, let's press -8 and press enter. It has said age cannot be negative. The raise statement triggers a value error with a custom message, which is this: age cannot be negative. So we have got that. The except block catches the error and displays the message. The except mass. If again I'm running this and press enter, so it's saying invalid literal for int with base 10 deed, then we are getting this error. That is the except block catches the error. This is how we can handle custom exceptions as well. So let me run a very practical example again once more to explain you in very easy way. So let's create a calculator. and then we copy this and this should be, we call it num2, sorry, enter the operation, and here we give a hint, plus or minus or multiply or divide. Okay, if operation, right? So this is for plus operation, of course, we know that. Then let's copy this. So instead of if, we are using it elif, for minus. So result is then again elif, and the last one, sorry, 0 division error. Okay, and result num1, sorry. Okay, and then we also use else, raise value, so we also handle value error as well. And then except we will catch error here. Oh, sorry. Right. Oh, I am getting this error here. Okay. So let's run this program. Sorry, we have not run this function yet. Sorry. Okay. So now let's run it again. So it's asking enter the first number. So valid inputs and operations display the result. So we say 12 and now enter the second number. We say 20 and it's asking enter the operation. So we say plus and it's saying result is 32. Thank you for using the calculator. So if you say, if you just look at this program, first we have entered the first number, then the line number 4, and then it has executed the line number 5, and then it has asked me if operation is plus, which we have entered. So only it has executed 7 and 8 line, not after that LFL, and after that straight away it has gone to finally line number 28, and thank you for using that. No exceptions, nothing. Invalid operations or division by 0 trigger appropriate error messages. So let's run it again. So we say 4 and then 0 and then we say dividing. We want to divide. So it will say cannot divide by 0. So straight away it cannot divide by 0. It has, if number 2 is equal to 0, raise 0 division error, cannot divide by 0. So it's so cool. Again, let's run it. And using else and finally for additional logic, we can the finally block thanks the user, ensuring a graceful exit. So let's suppose now we enter 4 and second is string. So it's saying could not convert string to float def. So this is because of value error. Line number 25 and then line number 26, and then finally anyway that will be executing all the time. So great job. In this video we covered what errors and exceptions are in Python, how to use try except blocks to manage errors, using else and finally for additional logic, raising and handling custom exceptions. Error handling is a vital skill for writing robust and professional code. In the next lesson, we will dive into working with files in Python. Don't forget to like, subscribe, and leave your questions in the comments. See you in the next video and happy coding. I will leave an assignment anyway for you guys. Thank you very much. Bye-bye.